EV battery fires and how they pose a significant threat. That's what we'll explore today, and why these incidents are happening more frequently, the science behind these dangerous fires, and the potential risks to drivers and first responders. So in this video, we'll see what the industry is doing to tackle this problem and how you can stay safe if you own an EV. Electric vehicles offer a promising path towards sustainable transportation. Concerns linger about the safety of their lithium-ion batteries, however. Unlike gasoline-powered cars where fire risks are relatively well understood, EV battery fires present a unique challenge: thermal runaway. This seemingly innocuous term signifies a cascading sequence of events within the battery that can culminate in a catastrophic fire. At the heart of every EV battery lies the lithium-ion cell. This cell generates electricity through a controlled dance of ions between the anode and cathode electrodes, separated by a porous membrane called the separator. Under normal conditions, this meticulously crafted balance keeps the battery functioning safely. However, a multitude of factors can disrupt this harmony, triggering the dreaded thermal runaway. One potential culprit is physical damage. A collision, a puncture from road debris, or even a severe impact during off-roading can compromise the battery casing. This breach exposes the delicate innards of the cell to air and moisture, and the resulting chemical reaction releases heat, initiating a vicious cycle. The heat further weakens the separator, allowing the anode and cathode to come into direct contact. This contact creates a short circuit, a surge of uncontrolled current that generates even more heat. Extreme temperatures, both high and low, can also trigger thermal runaway. Manufacturing defects, though rare, can also play a role. Imperfections or inconsistencies within a cell can act as weak points. These vulnerabilities can manifest as microscopic cracks in the separator or uneven distribution of electrode materials. During regular operation, such imperfections may go unnoticed. However, under stress, these weaknesses can become the spark that ignites thermal runaway. Electrical faults within the battery management system or charging infrastructure pose another threat. Malfunctioning wiring or improper charging practices can introduce electrical shorts, and these shorts create localized areas of intense heat, potentially triggering a chain reaction within the battery. Once thermal runaway begins, it becomes a self-feeding monster. The initial heat damages the cell, leading to the release of more heat. The heat, in turn, degrades the remaining cells, releasing flammable electrolytes and gases. The battery essentially turns into a self-heating container, spewing out combustible materials and escalating the situation. If left unchecked, this process can culminate in a full-blown battery fire, releasing tremendous amounts of heat and toxic fumes. Understanding thermal runaway is critical for addressing the safety concerns surrounding EV batteries. By identifying the triggers and the chain reaction it initiates, researchers and engineers can develop strategies to prevent its occurrence or mitigate its effects. This knowledge is the foundation for building safer batteries and ensuring a future where EVs can truly revolutionize transportation without compromising safety. While the risk of an EV battery fire is statistically lower than a gasoline vehicle fire, the unique characteristics of these fires pose significant challenges for firefighters. Unlike a gasoline fire that can be extinguished with water, EV battery fires present a complex and stubborn foe. The first hurdle lies in the extreme temperatures involved. EV battery fires can burn at a staggering 1,500 degrees Celsius, significantly hotter than the typical gasoline fire. Water, the mainstay of traditional firefighting techniques, becomes less effective at these scorching temperatures. In fact, using water can even be counterproductive. The reaction between water and burning lithium metal within the battery can generate flammable hydrogen gas, potentially worsening the situation. Extinguishing an EV battery fire requires a specialized approach. Firefighters rely on copious amounts of water for cooling, not necessarily extinguishing. The goal is to flood the battery pack and surrounding area with water to bring down the temperature and prevent reignition. This process can be extremely water intensive, demanding a constant supply and potentially exceeding the capabilities of local fire departments. Another challenge is the risk of revision. Even after appearing extinguished, residual heat within the battery can reignite the remaining cells, leading to a secondary fire, and this necessitates extended monitoring by firefighters who must ensure the battery pack remains cool for an extended period. This can significantly hamper response times and resource allocation during fire emergencies. The toxic fumes released during an EV battery fire pose a serious health hazard. Lithium-ion battery fires can emit a cocktail of harmful chemicals, including hydrogen fluoride, carbon monoxide, and nitrogen oxides. These fumes can irritate the lungs, eyes, and skin, and prolonged exposure can lead to serious health complications. Firefighters require specialized respiratory protection to mitigate these risks, adding another layer of complexity to the response. The challenges of EV battery fires necessitate a multi-pronged approach. Firefighter training must be adapted to address the unique characteristics of these fires, including proper cooling techniques and methods to minimize reignition risks. While EV battery fires raise safety concerns, it's important to consider them in perspective. Statistics show that EV fires are significantly less common than conventional gasoline vehicle fires. A study by the National Fire Protection Association in the U.S. found that EVs are much less likely to catch fire than gasoline-powered vehicles. Furthermore, the environmental benefits of EVs outweigh the fire risk. Transportation is a major contributor to greenhouse gas emissions, and EVs offer a cleaner alternative. The specter of EV battery fires, while statistically less frequent than gasoline car fires, demands a proactive approach to ensure the safety of this burgeoning technology. Fortunately, a multi-pronged strategy is emerging to mitigate this threat, paving a way for a future where EVs and safety go hand in hand. At the forefront lies the relentless pursuit of advancements in battery technology itself. Researchers are developing more stable electrolytes, the lifeblood of a lithium-ion cell, and these improved electrolytes will be less prone to breakdown under extreme temperatures or physical stress. Additionally, fire-resistant separators are being developed to act as a stronger barrier between the anode and the cathode. And finally, innovative cell designs are being explored to enhance their inherent safety. These designs may involve incorporating thermal fuses or self-cooling mechanisms within the battery pack, offering an extra layer of protection in case of emergencies. Another crucial line of defense lies in the ever-evolving battery management systems that govern the operation of EV batteries, also known as BMS. These sophisticated electronic brains monitor a plethora of parameters, including cell voltage, temperature, and current flow. Advanced BMS systems are being developed with the ability to detect potential issues early on, such as rising temperatures or imbalanced cell performance. Firefighters are the frontline warriors in any fire emergency, and EV fires necessitate specialized training and equipment. Fire departments are actively equipping themselves with the knowledge and tools to tackle these unique blazes. Training programs are being revamped to educate firefighters on the specific characteristics of EV battery fires, including proper cooling techniques and the risks of reignition. Additionally, specialized firefighting equipment is being developed, such as high-capacity water delivery systems and advanced thermal imaging cameras that can detect hot spots within the battery pack. Finally, public education plays a vital role in mitigating the threat of EV battery fires. Educating drivers on potential fire risks, proper charging procedures, and the importance of regular maintenance can significantly reduce the likelihood of incidents. Hey, we hope you liked today's video. If so, please like, share, and subscribe to our channel, and don't forget to hit the bell icon.